Welcome to the Network Engineering video blog. I'm your host, Michael Crane. Well, today we're going to do a sort of deep dive into the Xena Compact Gigabit test set. And we're going to, but first, I wanted to go back to our drawing of our lag testing, and this is the actual drawing that we used in the video when we were setting it up with the MX2s and the Zotac box. And you can see it's been kind of bumped around, half of it's erased. I'll update it here in a minute off camera and draw the Xena box in here. But what I wanted to do is before we did the deep dive into the Xena, I wanted to get an idea of what exactly we're looking for. Because it's one thing to kind of play around with the test set and run some traffic and that sort of thing. But you know, when you're really digging into something, you want to make sure you have goals. You know, like, so we know we want duplex traffic. We want, we don't want any kind of retransmissions of packets, like a connection-oriented type, like TCP, which is connection-oriented. And we want like best effort. We don't want to try to do any kind of policing or class of service type testing. So we want to keep it basic and just run some raw traffic through the lag. And before we do that, I want to set it up in the Xena in a loopback to make sure that we understand the statistics coming out of it, that it runs all the streams okay, and we don't really have any errors. And you should really do that with any piece of test equipment before you try to test with it, is put it in loopback and run it and get familiar with it and get familiar with the stats and make sure everything's running nice and clean before you try introducing your system under test. So I'm going to update this drawing and I'll be right back. Okay, so I've updated our drawing and I hope it makes sense. We'll go over it a little bit here. I've replaced the MX2s with the Xena box and the Zotac with the Xena box. And I know it's drawn as two separate boxes, but it's actually the same test equipment. I just split it up to make it easier to draw. This Xena up here is associated with port 3, and these are kind of the logical entities. And I left it similar to the previous drawing because it's going to be kind of the same kind of setup. I drew this little cloud around it because these are going to be like logical entities. They're all going to be using the same physical port as far as the traffic in and out. Down here, this Xena is associated with ports 0, 1, and 2. And they are also, they also have logical entities down here. And you can see the arrows where they go. This is going to go out. This is going to go in, out, in, out, in, and the same up here. That arrow is kind of, that shows going in, and this is going out. And so these two logical entities are going to be associated with port 0, these two with port 1, and these two with port 2. However, up here, all 6 of these are going to be associated with just port 3. And I don't know if you remember when we were looking at the Xena overview, I kept making a comment I couldn't figure out how to do the input, and I'm still kind of scratching my head how we're going to do that. So we're going to do the deep dive into the Xena Compact and see how to set this up. And before we put our system under test, which is the router and the switch and the lag, we're just going to keep this loop back like we did in the previous video. And just try to provision this will be a stream. So we already did that. We already created a stream from port 0 and went all the way up into, well, it actually went back into port 1 here. So it just went up and then through the physical interface down and then came into this port right here. And that's okay if you only have one output and one input. And so this is okay. But this right here is what I'm kind of wondering. So we know we can create streams. This is a stream. So we know we can create streams that will generate traffic out this one port, and we can associate them with UDP ports. So we can have 3 separate streams. That's not a problem. I am wondering how we do the input. And I know I told you I've used this box before, several years ago, but I don't remember how to set this up. So we're going to have a good deep dive into it, and you know, if I have to, I'll break out the manual. And the reason for this drawing is we need to come up with some goals for our deep dive. Okay, so I wrote out the goals for our loopback testing on the Xena. And the first one is we need to be able to set up where we can receive multiple streams on one port. Now, I'm pretty sure we can receive multiple streams on one port fairly easily. It's the next one, the next goal that I'm not really sure how to do, and we'll have to look into this, is I want to make sure we can see separate stats for each received stream. So if we've got all 3 of these things pumping traffic into this port right here through the lag, I want to be able to see the received stats for each one. So like if this one's dropping or this stream right here is dropping packets, but these 2 aren't, I want to be able to differentiate that. I don't want just one big pot right back here that says, well, I'm receiving 3 streams and somebody's dropping traffic. And I know we could probably get into the router and switch and look at that, but this is for a loopback. This thing, I want it to run perfectly in loopback mode. And that kind of brings me to goal 4, which I'll get to in a second. Number 3, I just wanted to point out that we're looking for UDP, best effort traffic, because I don't want anything trying to retransmit using TCP, and we're not trying to test any kind of class of service or type of service. So I just want just straight best effort. If it gets congested, just trash it, and because that's what we're looking for. And goal number 4 is I want the test set in loopback mode to be able to run 300 megabits of duplex traffic with no drops or errors. So because I know our system under test won't do that because of the overhead associated with the packets. And I should maybe put packet size in there, but it doesn't matter. But this test set in loopback we should be able to get it to run perfectly loopback. And then when we put our system under test in there, then we'll have a good idea of what's what the system under test is actually causing. Okay, so I went ahead and made a picture of the whiteboard so we could reference it as we're setting up the Xena box or doing our deep dive. Okay, so I'm going to fire up the Xena Manager. Okay, so I fired up the Xena Manager, and we've already had our chassis provisioned in there, so I'm just going to go ahead and reserve the chassis. And I don't know, do we already have ports? Oh, I guess they're not reserved. So I'm going to reserve port 0 and port 1. Okay. And I wasn't sure if it actually saved that reservation because in the previous video we had reserved both those ports. And I'm pretty sure you can run a test and disconnect and come back later and reconnect and still have the ports reserved. We'll have to look at that. I don't remember. Okay, where did we leave off? Let's see. We'll start with port 0. I believe what we did is we added some streams. Oh, here it is. Stream configuration grid. That's right, because we added the stream up underneath here, but I guess I didn't save it when I exited out. Okay, well, we'll add it again. And actually, it's got a setting to add multiple streams, so yeah, let's give that a shot. Why not? Let's see. We'll just start with 2. Okay. And let's go to stream 0. The traffic is off. Yep. Stream 0. Yep. And we might rename that later on so we know which is which. When we're doing our real test, we might name it so like stream 8888 and then something else receive 8888 or something like that so we know which one is which. But right now we're just looking at this. Okay, enabled. Yep, that's okay. Okay, so let's look at this is layer 2 information, destination MAC. Now we know from our last video that we definitely have to set that. Let's go into port 0 and source MAC. It's got ether type. Oh, we can say it's IP. And but we know we also need to add a transport layer. So, well, first I guess we have to add layer 3. This is layer 2. Let's see, we want IPv4. I know it's here somewhere. There it is. Okay. Well, let's go look at him. Version 4, header, DSCP. Okay, yeah, so here's the DSCP setting. And, yeah, we're just going to leave it best effort. Channel length. Identification, flags. Time to live. Protocol. Oh, this is kind of nice. Well, we'll say UDP. Header checksum, source IP address. So his source is going to be 192.168.1.10. Let's see here, 16.16. Destination is going to be 192.168.10.17. Okay. And okay, well, that looks good. Dig into some of that other stuff later. So, okay, so we need to add a transport layer. And we want it to be UDP. Okay. The resultant packet header is 46 bytes long. The Xena test payload TPLD will overlap the packet header for minimum size packet which may disturb proper test stream functionality. Well, we don't want that. I think we had that same error message in the last video, so we're just going to up it to 128. Actually, we should make it a lot bigger. In fact, I might, because it'll reduce the overhead, which is going to chew up a lot of bandwidth and screw around with our stats. But for right now, we'll just leave it 128. Okay, back to what we were doing. Okay, source port Source port is going to be 8888. Destination port is going to be 8888. Length, checksum. I guess that's if you want to change that stuff. Hopefully it automatically calculates it for us, but that should be good enough. Okay, so let's go to our other stream. And okay, his destination MAC is going to be the same, still going to port 1. Source port, it is going to be IP. And we'll close that guy. We'll add layer 3 here. Where is layer 3? There he is. Alright. And best effort, that's good. Error correction. Identification. Protocol. It's going to be UDP. Checksum. Looks like checksum's already calculated. Okay, so the source IP address is still going to be the same. So it's going to be 192. 192. 168.10. What, 16? Is that what it was? Yeah. Not 16. Destination IP is going to be the same too. 192.168.10.17. Right? I think that's right. Yeah. I still wish I had that save button. It freaks me out every time I close one of these things. Okay, so now for the transport layer. UDP. Yep. Oh yeah, gotta make sure. I guess it's nice it tells me instead of just trashing the packet. Okay. And source port. Okay, so this one is going to be different. We're going to make him 8889. And the destination port is going to be 8889. And we'll just leave all this other stuff the same. Okay. And I want to start them both at the same time. Oh, here we go. Traffic control, start. Now, I'm guessing that's going to start both ports at the same time. So let's go over here to port 1. He should be receiving some traffic now. And as you can tell, I still haven't read the manual yet, so you'll have to bear with me. Where was that? I got some global stats. There's some port stats. Let's look at some port stats. And let's see what we got here. Counter type. Total traffic. Okay. Getting 114 meg. Now see, I would have thought we would have got more than that, since we're sending 200 megs of traffic. Without test payload. Error injection, miscellaneous port receive stats. Okay, yeah, so total traffic for port. I guess this is it's also counting the header traffic. See, I think that's what the overhead's doing to you, is taking basically 80 meg of your bandwidth in overhead. That's pretty sad, huh? And oh, here we go. So test payload, port 000 running. And traffic ID 0, traffic ID 1. Jitter. Well, this is kind of nice. So it looks like it split it up. Stream, I guess, let's go look at stream 0 real quick. See if he says his test ID is 0. Oh, resource properties. Well, it says stream number 0. I guess that's test ID 0. I don't know. Oh, here it is. Test payload ID 0. Okay, good. And test payload. Oh, here we go. Stream ID, test payload ID. Ah. Okay, so 0001 is stream ID, test payload ID. Got it. So, okay, so back to the port. So, yeah, it looks like we're going to be able to get our, let's see, resource. Gosh, I forgot where to global stats. Is it under port stats? Yeah, okay. So, test ID 0. Source port running. Transmit receive running. Lost pack is 0. Misordered. Payload error. Bit error rate. Test payload traffic. Ah, this is what I was looking for. I want to see the... Okay, yeah, so here we go. So we're getting about 100 meg. It's funny, it's got bit rate layer 1, bit rate layer 2. So, yeah, you can see the overhead. That's pretty sad, isn't it? Okay, so next on our list is we just need to add 2 streams going back from port 1 to port 0. So, because one of our requirements was duplex traffic. Goal number 4. So, let's right-click on him, add multiple streams. I'll say 2. Okay. And so we got stream 02 and stream 13. That's a strange way of putting it. Let's see. Stream ID 0. Test payload ID 2. And stream ID 1. Test payload ID 3. Okay. Well, so be it. Alright, so we'll just fix these up real quick. We'll start with stream 02. And we'll go down here and let's say, okay, so this one's going to go backwards. So its destination is port 0. And its ether type is going to be IP. Alright. And we're going to make him IPv4. Oops, wrong one. IPv4. And best effort, yep. Time to live. Source IP address. So he is going to be 192.168.1.10.17. And he's going to 192.168.10.16. Yep. Okay. That's about it for that. Add another segment. We want UDP or transport. Oh, I think we're also supposed to give it the type. Oh yeah. I really should just fix that for you, but anyway. I think, is there a type protocol? Oh, UDP. Oh, it automatically fixed it. Automatically fixed it for us. Very nice. I guess as soon as I added UDP, it automatically fixes it. Excellent. Okay, so source port is 8888. Destination port is 8888. And everything else we'll just leave the same. Okay. Now let's go to stream 13. So his destination MAC is still port 0. Okay, we're going to add IPv4. I'm kind of curious. Let me cancel out of this. So it says ether type is none. Let me see if I add IPv4, if it fixes it, automatically updates that for us. Huh, it does. Excellent. Okay, let's see here. Foreign links, protocol. We know that'll get updated. Okay, so source is 192.168.10.17. Destination is 192.168.10.16. Okay. And we need some transport. Add. There it is. Oop. Yep. You know, Xena, you guys, instead of telling me to change it, you should change it and then pop something up saying you fixed it. So at least I kind of get why you're doing it. You're making the user change it so they know it's been changed, but you could automatically change it and say, you know, I have a pop-up with an OK that says change the minimum size to 128 to compensate for test overhead or whatever it is that you're saying. I don't even remember. Let's see here. Source port 8889. Destination 8889. And that should be about it. Okay, so let's fire these guys up and we should see traffic going back the other way. Start. Okay, so let's go to port 0 here. And we want to go to port stats. And it's the reason why it's the GUI is running so slowly is because of my screen capture software. It's if I turned off my screen capture software, it'd be running much faster. Because right now, the screen capture software has a CPU pegged at 100%. So, anyway, just thought I'd bring that up so everyone doesn't think it's the test set. Okay, so we got test ID 2 and test ID 3 running. And, oh, yeah, here's my traffic. Excellent. That looks good. So, test payload errors. Not seeing anything. Test payload latency. Jitter. Mark, save. Save. What does that do? Oh, looks like it's just going to save the data. I thought maybe there was a save button here, but that I was missing for provisioning, but unfortunately no. So we don't want transmit stats. We want receive stats, ping request, ping replies, frame checksum errors, gap count, gap duration. So on the this stream configuration, I believe it is. If you uncheck the show read-only columns, you can get in here and I think, let me make sure I'm not lying to you. Oh, yeah, you can still inject errors. So, yeah, so we should be able to, I'm guessing this is a frame checksum error. Oh, here you go, yeah, payload integrity, test payload error. I'll just do a checksum error. So inject error, inject 2 errors on that one, 1, 2, 3 on that one, and 3, 4 on that one. And this is kind of nice, and you might be thinking to yourself, you know, what's the point? And the point is so, like, you know, if you go over here to the stats of the port, and let's see, oh, I'm sorry, it should be the stats of this port. This is going to be the receive side. And yeah, see, you can see the frame checksum errors. And you go down here, and yeah, so we got 3 and 4 errors, which is right. So the last two is we did 3 and 4, and then on this side over here, I guess we should have 1 and 2. FCS errors. It says lost packets 1 and 2. Oh, FCS errors 3. Well, it just added them up. Yeah, see, and that's kind of. So yeah, it says up here we got. It says test payload errors, but we actually did FCS errors, but it just totaled them up. So I did 1 on test ID 1, stream ID 1, and 1 on stream ID 2, or TID, whatever that is, test ID, I guess. And it just added them up, and on port 0 there should be like 7, I guess, right? Yeah, see, 7. And I kind of wanted them. I mean, it shows that there was some kind of error, 3 and 4, which is correct, but maybe we can go back over to the stream config, and instead of sending FCS errors, we can send payload errors, which, and back to what I was saying, the reason why you do that is to make sure that you're actually looking at the correct stream. I mean, all of them are identical, sending all the exact same amount of traffic, and you know, everything's identical, and so it's good to be able to inject errors in different streams, and then just do a sanity check, go on the receive side and say, did I get this error? And that's good for that. It's also good for, you know, so the system under test should also peg a counter if it has such a counter. The test payload it probably won't notice because that's just for the test equipment. But the FCS it would probably pick up. We'll take a look at that when we start doing some testing, what errors we can inject and what counters on the equipment we can look at. So I'm going to do the same thing. I'm going to inject 1 on TID. Well, this is kind of confusing, but we all know it is. So we got 1, 2. Oh, here it is. 0, 1, 2, and 3. Okay, so we did 1 on 0. 2 on the second one. 1, 2, 3 on the third one. 1, 2, 3, 4 on the fourth one. Now we should this test payload error should be correct. So let's go over to port stats, TID 2 and 3. Oh, I didn't clear them out. Oh, that says packets lost. Payloads errors. Huh. Payload errors. Well, how unfortunate. I don't know why it would have dropped the packet. Let me clear this out. That should clear up this FCS error. Yep. Okay, and yeah, let's do that again. I'm just going to do it on the last 2. Stream config. Let's do 1 on this one and on 2 on this one. Go back over here to the port stats. And well, I don't know. Are we not sending payload errors? It says test payload error. I'm
I'm at a loss. Oh, does it? What does it say? Oops. Where am I at? There we go. Well, the good news is it's not sending FCS errors anymore, but it just says lost packets. I don't know. We'll have to get Xena to comment on that one. I'm not exactly sure what kind of error it is and why it's showing packet loss and not payload error. Because unless I'm just missing something, it says test payload error. Is there another error? Payload integrity error, maybe? Let's try that one. Okay. Inject 1, 2. Oh, here we go. And I don't see anything. I'm pretty sure it's not on the other port. 2 and 4. Well, I don't think I cleared out those counters last time. Come on. There it is. Okay, lost packets. I'm going to just clear them both out and try this again. Okay. Okay, so let's go up here to stream config. I'm going to set them all for payload integrity errors. And we're going to do a 1, 1, 2, 1, 2, 3, and 1, 2, 3, 4. And so these two are heading towards port 0. So since we already have port 0 highlighted, let's go look. And yep, well, I'm still at a loss. That doesn't seem to do anything. Unless I did see something earlier that kind of piqued my interest, and it was under options, calculate UDP checksum. Attempt to calculate UDP checksums based on a static header with all 0 payload and no test payload. Oh, well, we don't want that. Another thing. Let's do this. Let's see if we can capture. Yeah, I thought I saw that earlier. I'm going to. Let's see how to do this. So I'm on port 0. Let's set it to capture. Okay. And oh. Oh. Is it just capturing away or what? Oh, let's launch Wireshark. I love Wireshark. Ah, what is all this? Let's see. Is he actually running? Doesn't look like he's running. Oh, I guess it just dumped whatever it captured into Wireshark as like a file, I guess. But let's look at it real quick. I noticed this red right here, which is Wireshark's way of saying there's a problem. It says export error malformed. Length field value goes past the end of the payload. So let's see. global. I think this stops all traffic. Yeah, looks like it's all stopped. That's kind of nice. And this is kind of a good area to look at all the stats at once. So let's go look at stream or test ID 1, whatever it's called. And stream, we don't want that. We want resource properties. Packet size. Minimum size, maximum size, payload type, incrementing. Let's go back over to global and fire it all up and see what happens. Okay, so everything, traffic without payload stats are injected error stats. Oh, we do see some errors here. Here we go. Clear counters. Clear. Come on. Well, it's not clearing them out. That's not good. How do you clear these things out? Integrity error. Save. Clean and active. I have no idea what that means. Clean out any inactive filter and TID entries. Oh. Okay. So let's go back over to port stats. And we're trying to inject some kind of payload error. So we're on, so let's highlight port 0. And okay, so here's our error. Stream config. Payload integrity. Let's do a test payload error. And I will just send one. And go over here to port stats. Well, we show one lost packet, but it's definitely not payload error. Stream config. Let's send one of these. Inject. Port stats. Nothing here. I think we saw something on global. Let's go to global. Injected error stats. Now we've got 8 integrity errors. I don't know how to clear this out. I guess it just got the one. But, yeah, see, it clears it out up here. That's kind of interesting, but it doesn't clear it down here. You can't right-click on it. You can't do anything. I'm baffled. Let's see if we stop it. Clear. Nothing. I guess we got to restart the application to clear the errors. I'm out of ideas. Anyway, wow, we've really kind of got off on a tangent there, didn't we? Okay, let me go back to global. So this is what I was saying about, you know, you want to do this type of what if and why isn't this working, because if you injected that error and didn't see anything pop out the other side, then you'd be wondering about your system under test. You know, is it Is it something's wrong with it? Is it dropping? Is it not provisioned correctly? I mean, you just really don't know. And so at least you know on Loopback, you know, the wire's not going to drop anything. So when it's Loopback and you're able to test it like this, you can really get a good feel for the test set and where some of the goofiness is and what you can use to do some real testing with. So I just figured out how to clear these injected error stats. This is a transmit error statistic, and even though clear counters you would think would do transmit and receive, it doesn't. You have to actually go to the port, go over here to port stats and say clear transmit counters, and then that'll clear it out on your global. So yeah, I don't know, Xena, you might want to fix that. That's pretty confusing. Okay, one of the things I also want to check, let's yeah, I have the traffic running. Let's go ahead and look at this capture and see if that makes Wireshark happier. Oh, it says length 1318. Holy moly. Well, no wonder it's not fitting in a 128 byte. That's, wow. Yeah, frame is 128 bytes. Wow, that's, okay, well, if it truly is 1318 bytes and it's only set for 128, I'd say the length field definitely goes past the end of the payload. Wow, that's okay. So well, I was wanting to do this anyway. 128 byte packets are too small. So let's go to global and turn everything off. There's probably a way to do it up here, I'll bet. Stop traffic. Oh, are some of these... Oh, they're still running? Oh, that didn't globally stop it? Okay. So, where are we at? So we're in extreme configuration minimum. Payload type incrementing. Now we notice that pattern should be fine. I'm surprised it doesn't fit in 128. Wow, that's... I must be missing something. I don't know, let's make it, let's say 1500 size. Fixed size. Fixed size 15. Okay, well, we'll just leave it like that. What's the other? Incrementing butterfly, mixed sizes. Okay, now you're going to see, one of the things you'll see is you'll notice the overhead. What's going on the wire is going to be a lot closer rate as what you're seeing in the Ethernet or layer 2 stats. I'll show you what I'm talking about. Yeah, so this bit rate here and this bit rate here are going to be a lot closer together, because instead of having a bunch of small packets with the, chewing up a bunch of overhead with headers data, now we're going to have a lot fewer packets. So let's go to global start. Okay. And oh, we're getting a bunch of errors now. I did something wrong. I clear these counters. Transmit. Wow. Did I mess something up here? Let's stop it. Layer 1, transmit bytes. Wow. How am I transmitting bytes? Let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, 6. Is that 6 gig? Well, let's just start a little bit at a time. Let's see if I'm getting, so he's transmitting and receive. Looks like he's getting some packet loss. Transmit and receive. He was dropping everything, it looks like. Well, we've done something wrong. Let's see if we can capture. Start. Okay. That doesn't seem to be doing anything now. Global. Okay, let me stop the traffic. Clear the counters. Clear counters. Clear counters. ¿Qué pasa? Anyway, okay, so, I don't know. Resource. Packet content. Oh, maybe I made it too big because of the header. Although it says maximum size 1518, I don't know. Pattern. Looks like it just sent nothing but zeros. I don't know. Let's see. Let's say 1300. 1300. 1300. And 1500. Okay, I'm going to see if I can start one stream at a time. And I'm going to start both of them. So it's sending 200 meg. I still can't clear these things out. Not sure what's going on there. So it's sending 200 meg. I guess both streams are sending. Let's go down here to the stream stats. Yep, both are transmitting. Okay, so let's see. Port 0, stream. I guess that's test ID. Oh, here it is. Test ID 0. And then port 1, or port 0, test ID 1. I don't receive. Should be receiving it on. Oh, here it is. Destination port, source port. Oh, okay, I got it. So it is looking at the receive side. Dang it. I want to look at what these errors are. I can't seem to find them. And how come I can't globally turn this off from up here? I keep having to click on global to stop everything. Well, darn. Our deep dive has drowned us. I am just going to have to pull out the manual and see. I'm missing something setting this thing up, and I have... Oh, here's stream errors. Payload error. Well, great. What the hell does that mean? Tell me, I want to see what it is. I can't capture it. And why is it still running? I went to global, said stop traffic. I want to stop everything. Okay, so when all else fails, start from the beginning. So I deleted all these streams out, went back up to the port, and added the IP address, because we're going to need all this stuff when it's connected to the real equipment anyway. And it'll also need to reply to ARP requests, so we can do that for both of them. He said I might as well do that. I don't think this is the default gateway, but it doesn't matter. It's not going to use it. Well, unless it tries pinging it, I guess. Let's go ahead and just make it correct. Do that for both. And that's right. Subnet mask and... Oh, reply to ARP. I thought I selected that. So that's a... See, when you don't know... Oh! Oh, wow. You can click way over here, so... Okay, reply to ping, we don't care. ARP ping, address, wildcard, no, we don't care. DHCP, we don't care. No multicast stuff, so, you know, all this is okay. So then, like I said, I deleted all the streams out, and I said, okay, I'm just going to start from the beginning. And I had to actually Google how to set the priority bit in the thing. I couldn't figure it out, and finally I was reading Wikipedia or something, and it said, yeah, you got to put a VLAN ID in there and tag it with the VLAN ID of 0. And so that's what I did. So what I did earlier, so the Ethernet frame, I guess I could go through it, but I don't know if it's necessary. So the Ethernet frame is the same, except under this type, I originally had it set at IP. I set it for VLAN, okay? And it kind of stumped me for a bit because I was expecting something else to pop up here that says, you know, enter your VLAN information. But no, you have to go to add segment, and then scroll all the way down and add the VLAN header information, if you will. And if you Google Ethernet VLAN header, you'll see where it injects it. Anyway, so I went in here and added it, and it defaults everything to 0. So this is like the priority bit, and priority bit 0 is like default best effort, if I'm not mistaken. Yeah, so 1 is background, 0 is best effort default. Okay, so that's what we want. And this is a congestion bit, and so we just set, I think it's 0 is good and 1 is bad. You know, so like if you have something that's getting congested, it tags it with a 1 saying, you know, further on down the line it can, or let me back up a little bit. What it does, if you're running traffic and you're oversubscribed, in other words, you've bought 10 meg worth of traffic and you're running 11, it'll start setting these bits to 1 on that 1 meg saying, you know, this is drop eligible. I think that's what DEI stands for, drop eligibility indicator or something like that. And then this is the VLAN tag ID. And I set it to 0. So, you know, all's good. And the rest of the stuff is the same as what we did later. And so, you know how I was trying to do the capture and everything. Well, I found if you just right-click on this stream, you can do a preview stream. And that's really nice. Thumbs up to Xena for adding that. And unfortunately, though, my streams, although they're not getting any errors anymore, I'm not sure what fixed the errors. I don't know, something might have got corrupted or what. But if you go, so you can see here's the VLAN header. It's stuck in there. But look at it didn't none of my stuff. Look at that ID. I set it for ID 0. It's got 3658. And the priority is 1 instead of 0. And this is the drop indicator, and it's showing 1. It's nothing like what I provisioned in it. I am just baffled. So anyway, I'm gonna stop this video now, and I'm gonna have to do some research and maybe get Xena involved and see if they can answer the question of what's going on here. First, I'll read through the manual. I'm not gonna pester Xena until I actually look at the manual. I hope you found this video somewhat interesting. I'm gonna cut it short so it's not too long, but there's a lot of good stuff in here. We dug into this a little bit more, and I'm starting to feel more comfortable with the stats, which is really good. I think we're gonna be able to get some good test results out of it. And there's a lot more digging around in this thing we need to do, so I'm sure there's going to be another video. So I will see you later.